Back on time from the break. The good news is we have at least one other break for you. You are obviously in the red track, kleiner Festsaal, where we'll be discussing more IoT-specific security issues. It's my pleasure to present the next speaker, Dr. Schmiedecker from SBA Research in Vienna. He's specializing not just in IoT, but he's actually focusing on digital forensics. We had a larger live forensics project last year with him. The stage is yours.
Thank you very much. Good evening, everybody. Thanks for showing up on time, and welcome to my presentation about IoT forensics. So just a brief overview of what I'm going to talk about. Of course, what is IoT? I'm in the beneficial position that I'm the first speaker this evening, so I can do all the definitions as the first speaker, so all the others will be just copycat. Then I'll talk, of course, about doing forensics in IoT and what there already exists, which we can recycle. And then I'll give an outlook of what is going to come. So the first observation in questioning what is IoT, everything is connected. So the fridge is talking to the, I don't know, vacuum cleaner, washing machine, and they all chit-chat about talking what's going on in the flat and talking about protocols and things that happened in the past. And this is the core observation in IoT. Everything is connected, everything is talking to each other, and this can, as we will see, be problematic in the future. So on the internet, nobody knows you're a fridge. Well, actually, people know that you're a fridge. So this has been observed, I think, in Walmart or any retail store where there was a fridge and it had a web browser built in, and somebody was browsing Pornhub on this fridge. And the funny thing is that actually not only the fridge, of course, knows that it's a fridge, but also the porn website knows it, because in the user agent it's deliberately saying, hey, I'm a fridge and I have this resolution and I can do JavaScript and CSS, but cannot do HTML5. I do not do Flash, hopefully. Yeah, this is what we're currently faced with as security professionals. Apparently somebody had the wonderful idea to have a cookie oven connecting to the internet. I can't think of any use case where this would be beneficial. I really can't. I just don't know when the cookie machine would need to get a recipe. I mean, it's just an oven. There's no need for mixing milk and flour together and doing all the things. So, yeah, apparently people think it's a good idea to bring everything online. And as we've just seen last week, this is not the best idea. So the theme of tonight's evening is perfectly fitted to events that happened just last weeks and the weeks before with the Mirai botnet and the large-scale denial of service. In fact, the largest denial of service attacks ever observed on the internet, which was caused by surveillance cameras, toasters, and fridges. So why is this a problem from the perspective of digital forensics? In digital forensics, and also in incident response, the first thing you do is you take an image, then you go to the lab, and then you analyze the image. This can be tricky if the thing to acquire is a fridge. I mean, you can take the fridge to the lab, and then you have another fridge in the lab, but it can be tricky. IoT also means that sometimes you won't be able to find those things. They are in light bulbs. It's hard to imagine a home where everything is connected. And just imagine going with a checklist. Okay, I have the lamps, I have the vacuum cleaner. Where is this cookie oven? I cannot find the cookie oven. People really, yeah. So image acquisition is tricky. And then you have this gigantic fridge. You have it in your lab, and you think, okay, where is the hard drive? How can I get this thing? And even worse, how can I acquire RAM image to get the content which is dynamically managed by the operating system? What will also become troublesome is there are plenty and plenty of systems, like a diverse set, everything from small fridges, big fridges, cars, and all the things which will be connected, which will be talking network protocol. And of course, what can possibly go wrong will definitely go wrong. There was a nice article just, I think, last month, where somebody had the idea to buy a smart lock, and they put it on their main entrance door. And the person was in a rush, was leaving, and the neighbor wanted to get, I don't know, something from within the flat. And what the person owning the house then observed was that the neighbor was shouting towards the door, "Hey Siri, open the door," and the lock opened. Which is not a good thing if you want to have a smart lock to prevent intruders to actually do this. Also, just as I said last week, Mirai botnet, a large botnet with more than a terabit of distributed denial of service capacity, has been observed taking off portions of the internet. Just read today, in fact, smaller African countries have been affected and have been offline for a week now. The University of Vienna, the Technical University of Vienna, has been offline, I think, 2 days ago for 12-hour-ish, at least parts of it. So this is very problematic if you think about it, that these things are connected. And in fact, actually, I hope Marcus will talk about this, how to identify.
Exactly the same.
Very good, very good. As I said, the benefit of the first presenter is I can do all the things and all the others will be copycats. Yeah, and if you think about things that you can connect to the internet, I just can't even think of things that would be a good idea to have online. So, IoT forensics, why is this a thing? Why do we need it? What is the thing which makes the IoT thingy really IoT? Of course, everything is connected. As I already said, you have the lamp, you have the vacuum cleaner, everything is talking to each other. What we also see is that everything is headless. So there's a fridge, you can have some form of user interface, but it's not the regular PC with a monitor. The light bulb has no screen. Also the vacuum cleaner has just a limited user interface. So getting the device and then operating with this device to make it dump all this RAM content over the network to somewhere else is going to be really tricky. Also, the devices are very diverse. So you have different things, you have different operating systems. Everyone is hopping on the IoT train and trying to sell things that make them benefit. And, of course, the things are probably very small. You know, those are not that big. Yeah. But in fact, they are even smaller. So this is a Raspberry Pi Zero. You can buy it for, I don't know, 20 bucks. No?
It's out of stock since a year.
Okay, it's out of stock. So,
everywhere.
Yeah. So this is a Raspberry Pi Zero. Think about that. You could buy this online, and you can have a full-fledged Linux, full-fledged IoT operating system on it. And these are the things that we will be confronted with in forensics. So there's supposedly the RAM somewhere, but I cannot locate it. I have no idea where the RAM is. Also, there's no screen. You cannot just attach a monitor to it. Say, give me all your RAM content and dump it over the network. So this is the perfect example on what we will be confronted with in the future. Also, as I said, everybody's hopping on the IoT train. Intel is saying, hey, we have an Intel Atom processor, and it's x86 or AMD 64. Of course, they want to reuse all the stuff they already have, make it smaller, make it a bit constrained in power consumption, and then you have IoT. And of course, Windows, you have free Windows IoT core, which is supposed to take Windows to the Internet of Things. What could go wrong? No. So the good thing, and this is the key observation that I want to give you tonight, is that a lot of this stuff that we will be, a lot of the problems that we will be confronted with have been already solved. Wonderful example is you have a Google data center. Google does not see the computer as a PC, like a personal computer. They see it as things. And in fact, there's a right analogy between Internet of Things and the Google data center. Because if an entire racks in the Google data center fails, it's just replaced. Traffic is routed elsewhere. They are all headless. They are all small, and there are already tools available to deal with the challenges that we will have to deal with in the future. So what I'm going to talk about in the next few minutes, just briefly, and I would like to introduce to you, is tools that are already used today in large-scale environments to facilitate incident response and digital forensics. All the big companies, Google, Facebook, and Mozilla, they have decided on building their own incident response software, their own capability in capturing the software. And what I would like to see, what my vision is, everything from toaster to the fridge will become more powerful. They will host a full operating system, any Linux, Windows 10, and we can reuse the things that are already there, open source, and use them to facilitate incident response on fridges. So just a few words about Google. Google has the challenge, despite having wonderful pictures of data centers which look like art to people, they have the problem. They have hundreds of thousands of machines, and they need to figure out what is happening inside of them. So they need to monitor the load, they need to monitor if something fails, they have to detect it, and they have to react. And of course, security-wise, they have to be ready for incident response. So if some intruder gets into one of the core systems of Google, it would be kind of interesting to figure out on which actual systems the attacker is. You cannot just shut down Google with all the machines and then rebuild it from scratch, like the hospital in UK just this week in the news. You have to do it on the fly, and this is, of course, very challenging. Yeah, so this is why they built GER, Google Rapid Response, or GER Rapid Response as it's branded now. As I said, open source, and they use it internally for all the servers and all their client machines. So every machine at Google runs GER, or at least that's my impression. I've never been at Google, so I cannot tell. I can just tell what I've read. And it supports Windows, OS X, and Linux. In the future, if Apple is finally bringing that car, I don't know, it has the high capability that it might eventually be able to run GER. GER is open source. You can go on GitHub. You can do everything open source usually. They also have a mailing list, and they already have the capability to run on a Raspberry Pi Zero, for example. How does it work beneath the surface? So for one, they have local agents which run, lightweight agents which run on the machine to be supervised. So they have part of the, I'm not sure whether it's part of the operating system or not, but they have agent software which runs on the clients, which can then be tasked remotely. I cannot imagine somebody going into the Google data center trying to figure out with a screen the one machine which is currently blue screen and trying to reboot it. That doesn't scale. So on the good side, what GER, since it's already 5 years old and it's in use in production in Google, it has a web GUI. I could show you some generic stock images from the website how GER looks like. But basically it's a web interface, and you can task queries to all the machines and do all the things you would like to do in incident response. You could ask them, hey, which is the computer which has currently a network connection to this IP address in Russia, China, wherever you think your attacker is. And all the machines will receive the task and process it, and within an hour you have the answer of 100,000 or plus machines. It scales Google style, so there are not incidents, but there are hearsay in the community that they have, or someone has setups with 100,000 and more machines. So this can be very powerful. It's, if you have the web interface, you press reload and then you see the first 50 of 100,000-ish machines all waiting for you to task them. What they also have is configuration and rollout is easy. So what GER creates here is a binary, which is without any user interface, without anything. You can just push it out to all the clients. They will run it and then connect back to the server. And they have long-term Google support for it. So this is going to stick around for a while. The downsides of GER is it's not yet strictly user-friendly. So if you have that web interface, you need to be you need to figure out your way around. You need to have someone to show you how it works. The initial setup of the server can be tedious, so even though they use it internally and it's based on Ubuntu, it's not that straightforward to set it up. And of course, if you think about it, it has a lot of privacy and legal implications. So if you work in a company, you cannot just simply roll out this rootkit stylish software which can respond to your queries within seconds. But yeah, I'm sure legal persons will find a way around that. The good thing about GER is, as I said, the clients are lightweight, so all the magic happens at the server. The server also generates the executables with the config, so once you change the config, the executable is repackaged with the new configuration and then pushed out to all the clients. The client simply runs it and done. On the Windows side, there's not even a setup screen where you can click next, next, next. If you just open the binary, it will do something. You see the sand clock, and that's it. In the background, the process is spawned, the network connections are handled, and everything is done transparently. Also, the clients try to have a low footprint. I can imagine that if you have the Google data center and all of the machines at once try to have a disk seek for a specific file or a specific signature, this is not desirable. So the the agent is lightweight in a way that if it takes too much resources, it's killed. Yeah. The deployment is easy if you have group policy on Windows, you have Puppet or any other distributed system config management thingy. Just push out the binary and you're done. And also offline client will run the task as soon as they're back online. So in their presentation, Google says, yeah, there's this this person in Southeast Asia currently on vacation, but they're occasionally checking their emails, and they have some weird connections coming from that machine. Then they will just task the GER engine to give them the information they need. And as soon as the laptop goes back online, it will fetch the task and execute it. And it's done. Even if internet connection is really, really bad. So another tool which is in use by Facebook, has been in use and developed by Facebook, is osquery. It's kind of, you can always, between those tools, you can map the capability. You can use them for different kind of actions. osquery was specifically designed to have an SQL-like syntax to query specific artifacts from the operating system, and to have this be done in a regular interval. So in this SQL-like query language, every techie knows SQL, you can simply make the tables work for you, and regardless whether it's Windows, Linux, OS X, or FreeBSD, this will be answered as well. Again, open source, you can go to osquery.io, download the source on GitHub, and figure out what's going on with your machines. The scope of osquery is a bit different. So Google GER was specifically designed for incident response. Things like, okay, we have this weird connection from the machine, which kind of processes are running on it. osquery was more like, you can do the same things as I said, but it's more like into capturing the characteristics of the system. So figuring out which of the servers have a high load, or which are the servers with the most number of running processes. Also, you can have file system access, you have network systems, and so forth. And all the funky forensic things like Yarrow rules or indications of compromise. No, it's not indication, but you can find IOC artifacts once you have a root base. And push this out to all the clients. This is what a query looks like. I'm sure people here have seen SQL before, so it's like select from where, classic SQL query to get all the network interfaces, the MAC addresses, and the IP addresses for each machine that is tasked with this query. The third kit in the block is MIC, Mozilla Investigator. Again, the shift is more towards GER, so you want to have incident response. You have specific files which are interesting, might be worth investigating. And since it's written in Go, it is rather new, 2013, supports Windows, OS X, and Linux. And what you can do with MIC is, again, get the list of running processes, get the network information, for example, locate a MAC address, and this is what Mozilla uses to figure out what's going on in the networks. So as soon as you have 20,000 machines or more, it's really hard to get a picture of which machine is doing what, and this is why these different tools have been developed. The good thing about, or the key, one of the selling points of MIC is that it runs on switches, so you can just pipe in your switch infrastructure, and the backend is PostgreSQL. I forgot to mention it, but GER, for example, uses, of course, Google BigQuery. There, no SQL thingy, but you can also do MySQL. All right, so now you have all three tools installed on all your toasters and fridges. Now you want to figure out, and this is what Marcus, I think, will also talk about, you want to dump the traffic of the entire network. This can be done with any TCP dump, Wireshark, you name it. But a specific tool which I would like to mention is Stenographer, which was specifically designed to capture 10 gigabit links. So as soon as your toaster and your fridge are using 10 gigabit network connections, this will become very, very handy. I expect this to be 5 years, not more. But then this will be really cool, because then you can just pipe all the traffic that these devices are doing to this, and then do some form of network forensics on them. Also, what I would really love to do, there's this one tool, MoonGen, which was published, I think, last year. The specific design of MoonGen, a scientific publication, I think, Internet Measurement Conference. What MoonGen does is it saturates 10 gigabit links. So it creates packets at a vast speed. And if you happen to have 10 gigabit network connections at home or in the office, I would really love to play with it, because I would like to have a fight between MoonGen generating the packets and Stenographer writing the packets, and see who will win. One has to win, I mean, but yeah, I don't have this at home, so I cannot test it, unfortunately. But again, as soon as the fridge and the toaster use these things, I will be ready. All right, so despite naming those tools, the thing I would like to emphasize here is that, of course, Internet of Things is coming. We already have it partially, and IoT forensics will be a thing. Turns out we already have a lot of powerful tools available, which can be used, which are open source, which might be there for persons like digital investigators, which need to figure out what is going on in networks and how to make their way to find root causes for incidents. Thank you very much.
All right, thank you, Martin, for this presentation. Yeah, any questions on IoT forensics? Yes.
Yes. But hello. All of these tools you said needs to have a client installed on those devices. Is that really the correct outlook to make forensic investigation on some machines, devices, or attackers?
It depends. Thinking of a company network, for example, the security department is really into having all those toasters and things be controllable. So I'm sure there will be the need for that. I think also it's a selling point. So if you have company X which sells smart fridges, I think it's a good thing that you can hand out the tools to do investigations. So if something happens, like you have some ransomware, I will kill all the milk in the fridge if you do not pay me 5 Bitcoin, then this would be handy. But I have mixed feelings if this is what's going to happen, because companies don't tend to give this kind of control to customers, of course.
Okay, thank you. Any other questions? Yes.
Yes, so my question is for the Internet of Things devices in homes for private people. I'm a big fan of security on end devices, so the agents are, I think, a good idea, but this would mean that, in fact, every home has to have this one central server where the agents report to. So do you think this might be a problem? Because I can imagine my mom setting up a server at home for reporting.
Yes, it is. This is never going to work, and you will have to fix it at Christmas time. But the number of devices is increasing. Like, you will have a NAS, you will have a second NAS in the basement for backup. These things can run these agents, and they are already remotely accessible over a web interface. So if your mom calls and says, hey, there's a message on my fridge saying me I have to pay 5 Bitcoin, then you can just log in and work your way through it. But definitely, I agree there will be no central point, even though Apple would like to, or other companies would like to have this. But yeah, good point. Yeah.
We had a lot of possibilities, big data centers like Google or Facebook will do. We call it forensic for IoT. IoT is connecting to the cloud, communicating with the cloud using a hub, maybe with a home. When you want to know what your IoT device in the home is doing, you have to control the connections to the cloud and from the cloud. But it's not easy, because a lot of tools, IoT tools, newer ways, will use TLS connections. So what can you control? You can't control it, you can't is the communication, is it true or is it bad?
Yeah, good point. As I said, I hope that there will be central control points being able to, for end customers to see this. But it's the same thing for every network right now. End-to-end encryption with TLS, strong encryption will be challenging, and it looks like Marcus will talk about that.
Yeah, at least we can discuss it, I don't have any slides.
Yeah.
All right then, thank you for the questions. In order to give people a chance to actually slip in and out, we have to stop questions. Martin will be around to answer future questions, so give him a big applause again.